At 4:17 UTC on October the 25th, Parker Solar Probe's downlink stumbled, then locked into a steady, narrowband heartbeat. It matched the cadence of the 3I Atlas, the interstellar visitor that exhales nickel, fires a jet toward the sun, and pulses with machine-like regularity. With superior conjunction days away, our brief blind window, the signal sharpened, as if delivering a warning before it slips from view. Inside NASA, systems move to contingency posture. What follows is a calm record of the alarm, the patterns, the metal breath, the impossible jet, and the decision no one wants to make: fragmentation, persistence, or change. At first, everyone in the room thought it was a hiccup in the stream. A soft rise, a soft fall, a soft rise again. A heartbeat that wasn't supposed to be there. It showed up just after midnight on October the 23rd in the particle flux feed from Parker Solar Probe, tucked between the usual gusts of charged dust and the familiar noise of the inner heliosphere. The numbers weren't dramatic. They never are when something new enters by the side door. It was the regularity that caught the first analyst's eye. The crest-to-crest spacing kept settling at the same span. 11 minutes, 14 seconds. Once might be a glitch, twice might be a compression artifact. 3 times after the probe had slewed a little and crossed a different patch of solar wind, began to feel like intention. Protocol said, flag it as suspected interference. The engineer on the night desk did exactly that and wrote a neat line in the log, the kind that usually vanishes into 1,000 others by morning. But when the backup channel, different encoder, different clock, different path, showed the same spacing, the log note became an email, and the email became a call. By then, Parker had drifted a measurable distance, and the pattern should have drifted with the local particles if it was tied to them. It didn't. The pulse didn't care where the probe moved. It cared where the probe was looking. Someone threw the heliocentric coordinates of 3I Atlas on a secondary screen, more out of habit than belief. The interstellar object had already been the week's troublemaker, with its stubborn jet pointing toward the sun and that metallic breath that refused to match any comet model. Now, a new line was drawn across the room. The phase of the fluctuation lined up not with Parker's position, not with the bulk flow of the wind, but with a point just ahead of the path of 3I Atlas. The pulse moved as the sightline moved, as if the rhythm itself were anchored to the object's lane through space. Morning shifted the scene from a dim control room to a bright conference screen. Rotational models were the first to be tried, because rotation is the first refuge of order. If the nucleus of 3I Atlas had a spin that lined up just right, perhaps venting could fake a metronome, but the periods on file from earlier Hubble work and ground tracks didn't line up. Thermal cycles didn't line up either. They were too sloppy, too dependent on light and shadow. Magnetic background modulation didn't fit the timing or the phase. One by one, the usual suspects were asked to account for themselves. One by one, they shrugged. By early afternoon, the rhythm shortened. Not by much, less than 0.5%, but enough to make the hair on the back of a data scientist's neck rise. At nearly the same time, the best velocity estimate on 3I Atlas ticked down a whisper, a deceleration too small to carry a headline. The interval and the slowdown shrank together, as if measured by the same ruler. No natural plasma interaction makes that kind of neat adjustment. The meeting grew quiet. Jokes stopped. Someone asked to check the clocks. Another asked for the compression settings. A third pulled the backup feed yet again and overlaid it with Parker's new pointing. The answer didn't change. The rhythm knew where 3I Atlas was going and kept step with it. That was the moment the language in the notes shifted. Until then, these words were cautious. Anomaly, artifact, probable. After that, the phrasing hardened. Repeating interval, phase-locked correlation, external origin suspected. The tone in the hallway changed too. People stopped talking in the open areas and started leaning close. A second instrument team working a magnetometer stream that usually lives in the margins of attention peeled a faint echo out of the same time window, a broadband flutter with a thin dark notch near a familiar frequency. That notch had a bad habit of showing up in engineered systems as a deliberate gap, a way to carve out interference or carry a stamp. 2 probes, 2 paths, no shared hardware, and the same byte missing from the spectrum. It's here that the story slows down, not because nothing happens, but because everything that happens has to be checked. Every cable in the chain, every baseline, the long, boring heroism of verification. A software engineer walked back through the last 30 days of compression updates looking for a new behaviour that might fake regularity. Another dug out old calibration runs to compare clock jitter. A third pinged a colleague across the ocean and asked them to pull a slice of data from a different spacecraft entirely, separated by almost 3/4 of the Earth-Sun distance. If the 2 slices agreed on the timing and the notch, the odds of a shared mistake would plunge. They agreed. By nightfall on the 23rd, the internal one-pager carried its first unambiguous phrase: non-random periodic fluctuation correlated with interstellar object 3I Atlas. Longer reports stayed coy, but the people who had stared at the graphs all day no longer needed convincing that this wasn't the sun talking to itself. Something in the flow had started to carry intervals, pauses, returns, not noise, rhythm. There was still the matter of dignity. Science prefers to walk, not run. The senior people in the room insisted on exhausting the mundane. Could a bright, active region on the sun, rotating in and out of view, imprint a steady beat and trick the geometry? No. The beat tracked the projected path of 3I Atlas, not solar longitude. Could the probe's motion through a standing wave carved by some earlier CME create the illusion? No. The period stayed glued to the forward ephemeris, even as Parker moved across sectors. Could a groundside filter inadvertently smooth randomness into order? The backup path said no again, and the cross-check with the second spacecraft turned the screw another quarter turn. It would be easier if the numbers had been dramatic. They weren't. That's why the unease felt heavier. The peaks weren't towering, they were tidy. The intervals didn't shout, they arrived on schedule. You can explain away a roar. You cannot explain away a metronome that refuses to miss a beat. By the early hours of the next day, a small set of people outside the building knew. The safest way to move telemetry at this stage is quietly. Private channels between mission teams that know what to look for and what not to say. A handful of European and university partners were asked to pull their own slices, no commentary attached. The replies came back with the kind of neutral phrasing that means the senders are not neutral at all. Signature present, independent confirmation, not consistent with known effects. Inside, a separate group started doing what people always do when the ground shifts under their feet. They looked backward to see if they had missed the first tremor. With fresh eyes, an analyst combed older Parker data and found hints that the background had been whispering for days, maybe longer. The signal just too faint to stand on its own until the geometry tightened. The implication was uncomfortable. The rhythm hadn't arrived suddenly. We had grown still enough to hear it. This is the part of the story where the object's name, so clinical on paper, began to feel personal. Not because anyone wanted to turn 3I Atlas into a character, but because human brains give names to the things that stare back. And this, whatever it was, had started to stare back in the simplest way a thing can, by keeping time. The working hypotheses divided into 2 bins. In one bin lived nature, clever and stubborn. Maybe metallic grains in a weird crust were heating and cooling in a pattern that just happened to align with our instruments. Maybe the solar wind, folding around a conductive body, had found a way to sing. In the other bin lived structure. Not consciousness or intent necessarily, those are big words, but a system with feedback, a thing that senses its environment, adjusts and preserves its beat. Late in the day on the 24th, a small change tipped more weight into that second bin. The interval shortened just a fraction, and the notch in the spectrum shifted to keep pace with a subtle change in 3I Atlas's motion. The relationship wasn't dramatic, it was tidy again. The kind of tidy you see when a device retunes itself instead of drifting. The silence in the room this time wasn't the silence of not knowing. It was the silence of watching a line move to where a person would put it if they had a dial in their hand. If that sounds like overreach, it didn't feel like it to the people holding the plots. The safest words stayed on the page: phase lock, correlation, adjustment within measurement uncertainty. But the eyebrows, the careful breaths, the way folks cupped their coffee and didn't drink it, those were all the same language. You could feel the tone shifting from curiosity to containment, not because anyone wanted to hide a discovery, but because the shape of the discovery was not yet stable enough to set in public. In the best version of that restraint, it's caution. In the worst, it's fear of saying the wrong thing in front of the world. A junior analyst, the kind who still writes side notes in the margins, described the feeling in a way that stuck. "It's like hearing a distant train at night," she said. "You don't see it. You don't know its speed, but the spacing of the wheels over the rails tells you it's real and getting closer." That was the mood. The numbers did not shout. They clacked and clacked and clacked. By then, everyone knew to write 3i Atlas in full. A small superstition against turning it into an acronym you could ignore. The object's other oddities, the sunward jet, the nickel breath, sat in the back of every mind, suddenly less like separate mysteries and more like chapters of the same book. A narrowband rhythm that tracked its path didn't solve those earlier puzzles. It made them rhyme. Even the way the pattern refused to anchor itself to the local particles felt like a sentence. Parker crossed different sectors, and the beat didn't smear. It didn't change flavour with the wind. It followed a geometry, not a gust. That made it feel both bigger and simpler. Bigger, because anything that keeps time across distance belongs to a wide stage. Simpler, because the most efficient signals in the universe are the ones that only say now, 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 and let a listener infer the rest. The final act of that first 48 hours was small and decisive. The nightly summary, the one that a handful of people in other time zones would wake up to, carried a new first paragraph. The anomaly was now the event. The caveat still filled the page. The lists of alternative causes still took up most of the screen. But the last line of the summary was not a shrug. It was a statement of fact about what the instruments had seen, a repeating phase-locked interval that moved with the projected path of 3i Atlas and adjusted in step with its subtle changes. No one wrote the word message, no one needed to, if you were sitting at a console in those hours. The most striking thing wasn't the plot itself, it was the human choreography that formed around it. People who had never met found themselves speaking the same cautious sentences. People who disagreed about everything else agreed to check one more log, one more calibration, one more backup feed. The signal's strength didn't rise because it got louder. It rose because disbelief had fewer places to hide, and still caution. No announcements, no press lines. There's a kind of discipline that keeps hands off the send button until the third and fourth confirmations roll in. It's not romantic, but it's the reason good stories survive their first telling. So the rhythm kept arriving every 11 minutes and 14 seconds, and the people who heard it kept listening, and the object that shouldn't have been able to keep time kept time anyway. That's how the beginning really felt. Not like the discovery of a thing, but like the moment you realise the thing has been knocking for a while, and you finally decided to open the door. The first spectrum that made everyone sit up didn't look dramatic, it looked clean. Too clean. On the monitor, where most comets smudge into a forest of water and dust signatures, a set of crisp metallic lines stood up like radio towers on a flat plane. At the top of the plot, someone wrote what no one expected to write: nickel dominant. The room didn't erupt. It got quiet in the way people get quiet when they suspect they've just stepped over an invisible line. A spectrograph is a brutally honest machine. It doesn't care about stories or headlines. It breaks light into parts and tells you what's there. If frozen water is boiling out of a sunlit surface, you see the water's fingerprint. If carbon dioxide or carbon monoxide is escaping, you see theirs. If silicate dust is shredding into the wind, it leaves a sandy signature. That's how it has always been with comets. They announce themselves with vapour and ash, but 3i Atlas inhaled and exhaled like a refinery. The usual comet choir was missing. In its place, nickel and a faint, unsettling companion, nickel tetracarbonyl. On Earth, those two words belong to hard hats and warning signs. Nickel tetracarbonyl is a ghost that slips through seals, a perfect thief for carrying metal in industrial purification. It forms easily under the right chemistry and vanishes just as easily when heated. It is useful and dangerous in equal measure. Space, with its radiation and vacuum and raw sunlight, is a terrible place for such a delicate compound to survive. It should break apart almost as soon as it forms. And yet, there it was. Not once, not as a fluke, but again and again. The first reaction was the correct one: blame the instrument. In Chile, a technician pulled the calibration logs and looked for a residue spike that could fake a nickel line. The slits were clean, the lamps were steady. The control star taken minutes before 3I Atlas showed no such features. Hawaii ran the same checks, and then did something even more boring and even more important. They shut the dome for a short recalibration, purged the line, and opened again on a different target at a different angle. The nickel stayed with the object and nowhere else. Contamination is a patient liar, so the teams got stubborn. Filters were swapped, gratings were changed. A night was sacrificed to observe a handful of nothing patches, empty sky that should look like silence. They were silent. Then 3I Atlas rolled into the field and the plot lifted that same metallic comb. Meanwhile, at a whiteboard that had already surrendered to too many dry erase strokes, someone started tracking the ratio of nickel to iron in the spectrum. It is not a glamorous number. It's not the kind you tell your partner about over breakfast, but it matters. In normal comet outgassing, ratios wander. The sun heats one pocket, then another. Jets stutter and spin. You get a mess. Day by day, 3I Atlas tilted the ratio toward nickel. The iron grew shy. The nickel grew confident. If you've ever watched a refinery run, you've seen this movie. Material goes in mixed. Material comes out sorted. You don't need to see the pipes to know the process is working. The purity tells on itself. A senior spectroscopist, the kind who can read a line's shoulders the way a cardiologist reads a heartbeat, noticed something else. During the object's bright phases, the nickel lines didn't swell lazily. They snapped on and settled, then snapped off. Clean rise, clean plateau, clean drop, that is not how a hot surface belches. That is how a valve opens and closes. It would have been easy to stop there and start writing big words on press releases. No one did. Instead, the teams did the unglamorous work of killing every easy explanation. They checked whether the Earth's own atmosphere could be faking the pattern. It wasn't. The same curves appeared from sea level and from high dry mountaintops, and in spectra taken well away from any telluric traps. They asked whether starlight scattered through the instrument could imprint a false signature. It couldn't. The controls were clean. They compared their clocks to an atomic standard just in case a timing shift was smearing lines into illusions. The clocks held true. When the housekeeping was done, the nickel was still there, and the odd companion was still riding with it. Nickel tetracarbonyl. The phrase made the rounds like a rumour you don't want to believe. People pulled old papers, lab notes, hazard sheets. In industry, you make that compound by persuading nickel to bind with carbon monoxide under special conditions, then cracking it at a preferred temperature so the metal plate's out where you need it. It is the metal's carrier pigeon, the ghost that brings nickel home. The temperature estimates coming in from thermal models added a shiver to the room. The vented gas didn't look like ice flashing into vapour. It looked like a controlled release hovering around a band that purely by coincidence matched the comfort zone where that same ghost breaks apart in Earth refineries. Coincidences happen. When they repeat, you stop calling them that and start calling them patterns. Patterns, however, need geometry. If the chemistry is coming from one place, one set of pipes, the lines should point that way. They did. Every time the object flared, the metallic emission lined up with the same vector, the so-called primary jet, always pointing sunward, always behaving more like a decision than a leak. A comet is a spinning sprinkler. 3I Atlas was a pressure washer aimed straight into the wind. There's a reflex in science to carve the strange into the familiar. A few voices tried. Maybe the crust was rich with nickel grains forged in some ancient blast, and we were catching an odd pocket. Maybe cosmic rays had peeled the iron away over ages, leaving a nickel rind that just happened to volatilize with a cocktail of carbon-bearing gas. But each attempt stumbled on the same rock. The object wasn't just venting nickel, it was venting a compound that falls apart in sunlight and radiation. And yet the signature didn't fade as the hours passed. It held. That meant the source wasn't a one-time pocket being emptied. It was a reservoir. It was a process. Another oddity, the consistency. Astronomers love averages because reality tends to smear. Heat wobbles, spin jitters, lines fatten and thin. Here, the composition repeated within margins so tight they made people recalibrate out of habit. Nickel stayed nickel. The companion stayed in lockstep. The cadence of the chemistry marched with the cadence of the light. The most charitable natural model available, a weird mineralogical face that always rotates into sunlight in time, couldn't hold the beat without slipping. The object didn't slip. That's when the metaphors started slipping in. No one wrote them in the papers, they didn't belong there. But in the hallway, over coffee, people in this field started to use words like breath and lungs and skin. Not because anyone believed 3i Atlas was alive, because when a system takes energy in, transforms it, and releases a regulated product in measured beats, the body is the closest thing we know how to compare it to. The chemistry group set up a rolling checklist. Every flare event was tagged with its peak brightness, its duration, and the exact strength of the nickel signal. The correlation graph began as a suspicion and hardened into a ruler. Brighten the light curve, strengthen the nickel, dim the flare, soften the line. Not perfectly, because nothing in space is perfect, but so close to perfect that the imperfections felt more like instrument breath than object behavior. An engineer from outside astrophysics, brought in because sometimes you need fresh fingerprints on a problem, looked at the plot and said something that stuck to the wall like a magnet. "You're watching a cycle," she said. "Intake, conversion, exhaust." She drew a loop with 3 arrows and labelled them in pencil. She didn't say the words engine or plant, she didn't need to. The loop said it for her. Out in the network, the independent confirmations kept arriving. A small observatory with a temperamental spectrograph sent in a sheepish note. Their instrument isn't good enough to resolve the companion cleanly, but the nickel towered and fell on schedule. A radio team, listening rather than looking, reported a faint dip in a narrow band that often gets used to keep interference out of delicate equipment. A kind of absence that engineers sometimes add on purpose. It overlapped in time with the strongest chemical bursts, different senses, same rhythm. Inside the larger agencies, the wording stayed cautious, but something else changed. The cadence of internal requests. People started asking not only what the object was made of, but what the geometry of the emissions could mean for momentum. If you were to use sunlight to turn a chemical cycle that then releases a metal-rich exhaust, could you push a little? Could you nudge? The numbers that came back were tiny, almost laughable. But so is a heartbeat, if all you do is measure the force on your wrist. In the days that followed, a ritual took hold. Before sunset, a team would compile the fresh spectra and lay them over the prior days. Another team would fold in the light curve. Someone else would mark the moments where the nickel companion peaked. Each time the lines matched in ways that resisted accident. Each time the plateau of the nickel looked remarkably flat across the top, as if whatever was making it knew how to hit a target and hold it. And yet, no one with any sense claimed to have proof of design. That's not how proof works. Proof likes contact. Proof likes pictures. Proof likes a machine you can touch. What the data gave, reluctantly, steadily, was function. An object that should spit and sputter was breathing in beats. An object that should shed a chaotic mix of ordinary comet breath was exhaling metal and a compound you'd expect to find inside a sealed pipe on Earth. An object bathed in sunlight, it was releasing that compound at a temperature a refinery would choose. Late one night, a younger member of the team stayed behind after the others drifted home. On her screen, she stacked the nickel traces from a dozen flares on top of each other and traced the leading edges with a fingertip. The lines rose like disciplined soldiers. No laggards, no strays. She whispered a question into an empty room that no instrument can answer. "What are you doing in there?" There are explanations that can still save the old story. Maybe 3i Atlas is a strange relic from an environment we haven't modelled well enough. A place where metal and carbon met under pressures we don't see here. And the sunlight is simply teasing out a rare flavour of chemistry that looks, to our human eyes, like a plan. Maybe the regularity is a gift of geometry and luck, and the jet's aim is a quirk of shape and spin. Those explanations deserve their day in the lab and the sky. But while they queue up, the spectra do not blink. The nickel keeps arriving on time, the companion keeps riding along, the breath keeps smelling like industry. If you stand back far enough from the plots, from the arguments, from the careful phrasing and the career-saving caution, what remains is simple. 3i Atlas isn't shedding like a stone warmed by the sun, it's processing. You can change the words to make the idea less frightening, but the idea stays. There is intake, there is conversion, there is exhaust, and each time the light crests, the metal crests with it, as if down inside that dark core. Something takes a measure of heat and turns it into a controlled release. On paper, that is all you can say. In the voice that will carry this story to people who do not read plots for a living, you can say it another way. We pointed our best instruments at an interstellar object and expected to hear steam. We heard machines, and the machines kept perfect time. The first time someone traced the plume on the image, they used a ruler. It wasn't because the jet looked straight. Comet jets often do, at least for a moment, but because of what it was pointing at. It aimed directly into the glare, into the centre of the disk that rules everything in this part of space. Jets don't do that. They erupt from warm spots and get pushed away, fanned backward by light and wind like smoke trailing a moving train. But the line behind 3i Atlas wasn't a trail, it was an arrow, and the arrowhead was the sun. At small scales, illusion is easy. You can trick the eye with perspective, a well-timed flare, a smear of dust. So the teams did what careful people do. They tried to break the picture. A second observatory far from the first took the same frame. The parallax moved the background, but not the plume. A third telescope, watching in a different band, watched the brightness change. The length adjusted, the thickness breathed, but the direction held. The arrow kept pointing at the same target. A technician copied the images and flipped them, rotated them, inverted the colour table, did everything you do when you don't want your own brain to sell you a story. The jet stayed sunward. When Parker's field data came down, the geometry clicked into physics. Around a normal vent, the solar wind threads bend in a way that tells you matter is being thrown off and shoved back, the magnetic field lines draping like wet cloth over a moving limb. Around 3i Atlas, the lines on the sunward side were wrong on purpose. They bent away from the object as if something was pressing against the wind, not being bullied by it. You could see the pressure not as a bright streak, but as a shape in the invisible, a pocket scooped out of the plasma, a steady hand pushing upstream. That's not a leak. That's opposition. The numbers on the jet's size made the picture stranger and somehow more grounded. In infrared, where heat tells the truth even when light lies, the plume reached on the order of 11,000 kilometers along its axis. Too long to be a hiccup, too coherent to be drifting dust. In visible light, it looked faint and hesitant. In the near-infrared, it burned with confidence, as if most of the energy lived just past what eyes can see. Every time 3i Atlas turned, and yes, it turns, though not the way broken things turn, the plume's base flexed. Not randomly, not lazily. It pivoted to keep its aim on the same point on the solar surface, like a gimbal that knows its job. The first polite explanation was that we were seeing a second hidden jet. If a vent on the far side of a spinning body comes into view just so, it can fake an odd alignment. It's a real phenomenon and it fools honest people all the time. But it unravels when you watch long enough. A fake alignment slips with rotation. The geometry doesn't have the stamina to hold its lie. Here, hours stretched to days and the illusion never cracked. The aim corrected as the object moved. The base of the plume crept across the surface, finding new footing, while the tip never surrendered its target. You can't keep an illusion on target through that much motion, without choreography. 3i Atlas had choreography. The other gentle story was albedo. A bright spot can make a patch of coma glow and masquerade as a jet. It's happened before. Observers know the trick and they know how to beat it. Switch the band, watch polarization, measure motion. Albedo tricks are soft. They bloom and fade with angles and they don't push on magnetic fields. The albedo hypothesis died quickly and quietly once the magnetometer plots landed on the table. The polite phrase that replaced it in one public note, localized albedo enhancement, read like a sigh. It's what you write when your eyes and your instruments disagree and you're not ready to take sides on the record. When you picture the plume, don't picture a garden sprinkler. Picture a pressure washer. The beam doesn't wander across the yard, it is held and guided. The gas emerging from the base of the plume didn't stumble at a lazy drift. It left at a few kilometers per second and held a narrow lane like traffic in a tunnel. What narrowed it? Thermal vents love to spread. Magnetic guide does not. If the exhaust is ionized, a shaped field can pinch it, sharpen it, and direct it. That's how laboratory nozzles keep plasma from touching the walls. That's how nature keeps auroras in curtains across a planet's sky. And that is how a jet can stay thin when chaos asks it to bloom. Over and over, the same test ran in different hands. Take the observed thrust you'd expect from gas moving that fast in that volume. Take the torque it would put on a body this size if it were purely natural. Ask the spin how it feels. If the answer is honest, the spin should drift. It didn't. The measured rotation period sat there like a stone. Slight shimmy? Sure. The world never holds still, but no tumble, no runaway wobble, no need for a miracle of symmetry that would keep a randomly venting rock balanced on a fingertip for weeks. The simplest way to save the numbers is to admit a second hand is at work, something countering the torque. Here is where vocabulary gets you into the trouble. Say attitude lock and people hear spaceship, say stabilization and they hear control. But you don't have to dress the idea in science fiction to take it seriously. Any system that senses its own twist and vents in sequence to cancel that twist will hold its pose. You can build such a system with crude lungs and a good ear. You can build it with valves and timers. You can build it with fields. No declaration of intent is required to describe what the plots already describe. 3i Atlas resists being pushed off target. That resistance is not luck, it is behaviour. A timing quirk made the behaviour feel smarter than it needed to be. Small brightenings on the sun, little breathless flickers, not the grand tantrums, were echoed by changes at 3i Atlas, with a delay that made sense for distance. Not perfect, because nothing about solar weather is perfect, but close enough that a line drawn on a graph didn't look cooked. A brief uptick in solar flux arrived. The plume adapted. The aim sharpened or softened. The cadence of the flares dipped and swelled. If you'd wired a simple sensor to listen to the sun's heartbeat and open a valve on cue, that is what your printout would look like. Across a string of nights, polarization measurements added a faint layer of structure. The axis rotated by small repeatable amounts whenever the flares changed amplitude, as if an invisible nozzle were twitching along with the brightness. Polarization is the shy cousin of brightness. It doesn't wave its arms unless you ask the right question. The people who know how to ask saw the axis lean a degree here, a degree there. Every time the plume's power stepped up or down, it read like a textbook on controlled fields, except the textbook was moving at 30 kilometers per second and breathing metal. If you've never watched a group of engineers try to explain a behaviour they weren't expecting, imagine a jury of mechanics watching a car roll uphill in neutral. The first verdict is that the hill must be sloped the other way. The second verdict is that the brakes are sticky. Only on the third verdict does someone start watching the wheels with a hand on a coffee cup and say, very softly, I think it's under power. That was the feeling when the microthrust calculations came back. The numbers were small. humanly small, measured more by implication than direct line. But they pushed consistently in the right direction, and the direction was toward the sun. The push matters for a reason beyond surprise. Push into the wind long enough and you get a say in where you go. A tail blown backward is at the mercy of the weather. A beam pointed forward can trim and tuck, nudge and hold. The path of 3i Atlas, so weirdly precise for an interstellar visitor, looked less like a miracle of chance and more like the quiet work of a system that never lets the breeze make the big decisions. If the plume is only breath, it is the most disciplined breath we have ever measured. If it is more than breath, then it is a tool. Arguments kept trying to save the old story, and it is good that they did. Maybe the sunward jet is a strange cousin of a rare comet phenomenon, a transient known to leave spikes that seem to point upstream under special conditions. Those spikes, however, are short-lived tricks of perspective and particle size. They do not drag field lines. They do not hold alignment through rotation. They do not pivot like a head keeping eyes on a target. Maybe the nucleus is oddly shaped and the vent geometry is conspiring to keep a face pointed at the light. The trouble is torque. The jet should spin that face away. When the face doesn't drift, you have to find a reason that's not geometry. We kept circling back to the same place, behaviour. There was a moment in a late meeting when someone pulled up a composite, light curves, polarisation ticks, magnetometer wiggles, and the line of the jet laid over a solar map. It wasn't pretty, too many layers seldom are, but the mess told a simple story. When the sun's skin fluttered, the object reacted. When the object reacted, the plume's aim adjusted. When the aim adjusted, the field shape in the wind changed exactly as you would expect if the gas were pushing into the stream, not fleeing from it. Over and over, small cause, small effect, same direction. This is where the word engine crept into private speech, even among people who distrust that kind of talk. Not a roaring bell, not a fusion fantasy, not the thing the movies promised, just a cycle that takes light and heat, runs it through metal breath, and sends a narrow push in a chosen direction. Everything about 3i Atlas seems to prefer the modest version of the extraordinary. Small thrust, long time, constant discipline. No grand gestures, only a will not to drift. There's a detail easy to miss because it isn't dramatic. The jet's brightness in the infrared doesn't only tell you about heat, it tells you about density and order. In a natural plume, the farther from the vent you get, the messier the gas becomes. Vortices, eddies, clots of dust that make the line ragged and fat. The images from 3i Atlas show a core that stays narrow beyond where it has any right to be narrow. That's the signature of guidance. A field that pinches the flow protects its shape the way a well-made hose keeps a stream from turning into spray. Skeptics didn't go home. They asked for hotter tests. If the jet was simply a weird thermal vent, the temperature at the base should wander with sunlight and rotation in ways we can predict. The measured temperature sat near the same band night after night and refused to wander. They asked whether the plume might be mostly dust making mischief with the wavelengths. Dust leaves fingerprints. It scatters light in ways that betray grain size and composition. Those prints weren't present in the right places. The plume read like gas. The gas read like metal breath. What makes the whole picture unsettling isn't any one piece. It's the way every piece refuses to be independent. The aim explains the field lines. The field lines explain the narrowness. The narrowness explains the stability. The stability explains the trajectory that won't wobble under pressure. And in the middle of that circle sits the simplest observation of all. The jet points at the sun and doesn't stop pointing. It is not a dramatic image if you remove the context. A slim thread reaching into the glare. But if you sit with it, some part of your mind does the quiet math we aren't writing down, the kind that needs no symbols. For a thing to aim into the source of its trouble and grow steadier the closer it gets, it must be built not to fear the source. It must be arranged to drink from it. That's why even cautious people spoke, when no one was taking notes, about a system that uses the sun not as a hazard but as a partner. There's a practical consequence that has nothing to do with philosophy. A plume that can aim forward can talk forward. When a beam carries structure, timing, shape, and modulation down its own axis, the simplest way to send it somewhere is to point it at your transmitter. If the sun is the metronome, a jet aimed at the sun is both throat and ear. No one knows if that's what 3i Atlas is doing. The data only say the geometry is there. In the last clear frame before the world's instruments began to squint, the plume was in perfect form. The base looked almost too tidy, a foot planted, the body leaning in into a climb. The axis ran straight to the bright edge. You could overlay it with the day before and the day before that, and it would sit neatly, a stack of arrows sharing one target. It's a strange comfort, that kind of consistency. Whether you think you're looking at an indulgent comet or a quiet machine, the plume says the same thing in either language. I am choosing the direction of my breath, and for now, that direction is toward the light. They started counting because the pattern refused to stop. 1 tick became 10, 10 became 100, 100 became something you could plot on a single wall without running out of space. The cadence of the flares from 3i Atlas kept arriving like waves that never forgot where the shore was. Each crest rose when it should, each trough fell when it should, and the variance was so tight that people recalibrated their instruments out of habit, the way you tap a watch that's too punctual to be real. The most unsettling detail snuck in quietly. A tiny flash in the ultraviolet just ahead of the bright phases, the same small flicker, always a few heartbeats early. It didn't last long. You could miss it if you blinked or if the software smoothed the data, but when the team learned to look for it, they found it nested before almost every flare, like the click of a breaker before the lights come on. The delay between that pre-flash and the main blaze was eerily consistent. So consistent that a younger analyst wrote it down on a sticky note and stuck it to her screen, not because she'd forget it, but because she didn't trust her mind to believe a number that tidy without help. If it were only brightness, you could call it mood. But the chemistry moved with the light. The nickel line surged and settled in lockstep with the flare, like breath leaving a chest in time to a drum, and that made the sequence feel less like a weather pattern and more like a procedure. Intake, pre-flash, conversion, rising glow, exhaust, nickel crest. Then the quiet between beats, never long enough to be random, always long enough to be chosen. That's when they began to stack more than just light. A second team pulled the solar wind density Parker was sipping at the same time and laid it under the flare curve. Something beautiful and practical revealed itself. When the wind thinned, the flare grew bolder, as if compensating for the lost pressure. When the wind thickened and pushed harder, the flare eased off, as if saving energy where the environment already carried some of the load. It was a seesaw with purpose, push here, rest there. You can program that into a heater. You can design it into a governor. You don't see it in a vent that only knows how to blow. Everyone in the room had a favourite mundane explanation, and everyone took a turn trying to keep it alive. Maybe the cadence was aliasing with some rotation we hadn't modelled right. Maybe the ultraviolet flash was scattered light from a quirk in the optics. Maybe the correlation with the wind was an illusion born from too few cycles, but the cycles kept coming. The pre-flash kept arriving a breath before the flare. The compensation kept sketching its seesaw on the same axis. The longer they waited for the pattern to dissolve, the more stubborn it became. Like a melody you can't dismiss as coincidence once you've heard it hummed in 3 different keys. By the time the log passed 600 cycles, a nickname had stopped being a joke and started being a shorthand. Beacons. People didn't use it in memos. They used it when they were too tired to say those flares that behave like timing devices for the 50th time in a day. Beacon didn't mean message. It meant regularity with a job. If you were building a machine that had to hold its balance against a shifting wind and variable heat, you would give it a rhythm to check itself be. A heartbeat is not a telegram. It's a way a system proves to itself that it's still a system. A quiet breakthrough came not from a telescope, but from a change in attitude. Literal attitude, as in how the object held itself. Polarization measurements whispered that the axis of the emitted light tilted by a small repeatable amount whenever the flare strength changed. Not much, enough to say something inside the plume was twisting in sympathy with the brightness, like a nozzle tightening and loosening its aim. If you've ever put your thumb over a hose to sharpen the stream, you already understand the physics. The surprising part was not the sharpening, it was the timing. The twist happened in the same place in the beat every time. In the margins of those nights there were human rituals that told their own story. Someone would draw a little tick mark in the corner of a whiteboard for each confirmed pre-pulse. By morning the corner would be full of tidy fences. Another person, who pretended not to be superstitious, kept a running list of the few cycles that fell outside the tight envelope and circled them as if they were traitors. They never organised a party when the count hit round numbers. They were afraid the pattern would notice. The compensation behaviour, brighten when the wind is soft or relax when it's strong, felt like the hinge that connected everything else. It explained how 3-Eye Atlas could risk a narrow, sun-facing plume without losing control. It explained why the cadence didn't drift as the object moved into harsher light. The system was not simply enduring change, it was answering change. Even the nickel breath, that industrial ghost, made more sense in this rhythm. A compound that shouldn't survive long in raw sunlight could persist if it was being replenished on a schedule, fed by a cycle that knew when to load and when to dump, when to prime with a pulse of ultraviolet and when to crack and vent. What you couldn't see in any single plot became obvious when you layered them all. Light, chemistry, wind, polarization, timing. Each told the others when to move. The net effect was a body that never drifted far from its mark. Out of that loop grew a new question that no one had wanted to ask too loudly at first. If a system can regulate its breath this precisely, what else might it be regulating? So eyes lifted from the flicker of flares to the long, quiet sweep of path. 3-Eye Atlas had not been behaving like a visitor who stumbled in from the dark and was surprised by the brightness. From the first nights of tracking, its trajectory had traced a line so clean it made orbital mechanics look like calligraphy. It skimmed the plane of the planets as if it had read a guidebook. Its shallow tilt to the ecliptic was the sort of politeness you see in spacecraft that want to share the neighbourhood without making a mess. That wouldn't be remarkable if the rest of the behaviour were messy. A good accident is always possible. But the same discipline that ruled the beat of the flares seemed to rule the curve of the path. Observatories separated by oceans and languages kept taking the ski's measure and reporting the same thing. The expected little wobbles from planetary nudges weren't showing up as wobbles. Whether math forecast a tiny sag or a tiny lean over days and weeks, the object held the line. Or if it moved back, as if someone had quietly nudged a rudder while you were blinking. People who live and die by the fit of a model tried to break the news to themselves slowly. They reran the integrations with every plausible force. They added the push of sunlight, the drag of dust, the recoil of outgassing, the tickle of weak tides. They cheated in favour of chaos. Still, the curve on the sky matched the best fit line more closely than the best fit line had any right to be matched. The final refuge of the cautious was to call the match luck. Luck, like coincidence, is a good word for the first hour. It grows thin over the course of a month. Doppler readings added their own whisper to the room. In a messy body that vents and spins and flakes into plasma, the spectrum of speed blurs. Not here. The line was narrow in a way that made people sit up straight. Not narrow like a polished bell. Space always adds a bit of fuzz to every measurement. Narrow enough to say this is behaving like one thing, not a crowd. The difference between a choir warming up and a single voice holding a note. At this point, the conversation between the flare watchers and the path watchers started to sound like agreement. If you assume a breath that can be aimed and modulated on a schedule, a small steady push appears in your math. You don't need a grand engine, you need persistence and patience. Push for an hour and you do nothing anyone can boast about. Push for a month and you erase the little slips that gravity and pressure would otherwise write into your story. Push for longer and you can decide not just how steady you are, but where you end up. No one pretended the push would be big. The best estimates lived in the land of tiny. That was the point. You don't need a shove to write a straight line across a long distance. You need a finger you never lift. There was something morally satisfying about that to the engineers in the room. It's the same logic that keeps a tight orbit tight. Constant, intelligent correction beats bold, careless moves. If you want to know why this precise path felt uncanny, you have to look at what it refused to do. It didn't precess the way it should have under asymmetric outgassing. It didn't drift off the plane the way an interstellar body often will when it has no reason to care about our architecture. It didn't pick up a spin wobble from being breathed on at an angle. Each missing flaw was an absence you could measure. Each absence had a corresponding habit in the data where the object seemed to neutralize the cause as fast as it arose. Some called it mean motion discipline. Others, less charitable, called it denial of service to chaos. The quiet humour in the halls couldn't disguise the stakes. If 3i Atlas was holding course because its breath was a clever stabiliser and nothing more, the story was still astonishing. Nature would have built a regulator out of metal and heat. A machine without a designer, just a set of properties that happened to harmonise. But if the same rhythm that regulated heat and pressure was also flattening the wiggles in the path, the line between as if and because began to blur. The path did not merely happen to be precise, it was being kept precise. There were other planar checks. Teams looked for the subtle lag that should appear when a path leans into a nudge from Mars or Earth and then slowly bleeds that energy away. The lag never developed. They checked whether the line of nodes, the place the path crosses the planetary plane, drifted at the rate you'd expect from sunlight and outflow. It stayed put, or if it moved back by the time you checked again, like a door that closes itself after every bump. A late-night meeting produced a document with two plots that made even the skeptics lean in. The first showed the flare cadence and strength over weeks, a clean, stubborn heartbeat that only small, orderly things could disrupt. The second showed the difference between predicted sky position and measured position over the same period. The difference wiggled, then flattened, then wiggled in the opposite direction, then flattened again, always within a narrow band, always the kind of curve you get when a system refuses to let error accumulate. You could look at those two plots side by side and tell yourself a sensible story. The beat isn't just for heat, it's for control. There is a phrase people only say out loud when the doors are closed. They say, "It flies like it knows how." No one meant awareness in a romantic sense. They meant response, the kind that uses information to keep a course. 3i Atlas moved through pushes and pulls with the poise of a swimmer who has learned the current, not by reading a manual, but by practicing until muscle memory takes over. To us, from here, muscle memory looks like intention. By then, even the unflappable started carrying two scenarios in their heads like matched weights. One, a natural body in a freakishly favourable configuration, breathing in a way that cancels its own clumsiness, holding a path that would make anyone proud to plot. Two, a system whose breath is a tool and whose tool is being used. The difference between those scenarios doesn't show up in a single pixel or a single line. It shows up in the feeling you get when you watch a path that could fall apart at any moment and never does. As the days ticked toward the blind stretch behind the sun, the flares did not get sloppier. The beacons did not wander. The path did not show nerves. That composure may be the most remarkable trait of all. Many things can be brilliant for an hour. Stamina is harder to explain. 3i Atlas kept time and held line, with the humble grace of a metronome you can't make skip, the quiet defiance of a mark you can't erase. If you trust the simplest story the data can bear, a picture emerges that is stranger than fiction and easier to believe than denial, a rhythm that steadies breath, a breath that shapes a plume that pushes, and a push small and faithful that writes a straight course through a messy world. The silence didn't arrive like a slam of a door. It came as a soft closing of drawers, a missing line item here, a delayed upload of there, a pending calibration tag where yesterday there had been fresh graphs. People who live inside data streams feel these shifts in their bones. The first hint was the gap in a public index that usually reads like a train timetable. A sequence of catalogue numbers jumped, as if a handful of cars had been decoupled in the night. No announcement, no red ink, just a skip where several days of images should have sat, precisely when 3i Atlas crossed a geometry sweet spot for crystal clear views. The official language was harmless enough: glare, interference, routine review. Anyone who has ever nursed a fussy instrument knows those are real problems, and sometimes the only honest response is give us a minute. But the timing put a burr under the saddle. The missing sets lined up too neatly with the object's sharpest behaviour. The same days when the rhythm tightened and the plume trimmed itself into a pencil line aimed at the sun, the messaging from the largest desks grew careful. The calendar for a major space telescope, which had proudly listed a program pointing at 3i Atlas, quietly replaced the target with a blank placeholder. You could still find the original entry if you dug through archives like a ghost of a plan that had changed its mind. Inside the halls, the mood shifted from noisy excitement to the specific quiet of people who have been told to be precise with their adjectives. Shared drives that normally filled with raw frames began to fill with summaries. The footnotes grew longer even as the figures grew fewer. You could hear the reason, and it wasn't cartoon secrecy. When a story threatens to outrun its supporting numbers, institutions that are built to be trusted tense up. No one wants to set the internet on fire with a plot that later turns back into ash. Even so, the blackout had texture. A slim, quickly deleted image from a European terminal showed a slope on a thermal curve that didn't look like ice sweating into space. It looked like heat walking through layers. A magnetometer team posted, then retracted, a phrase that read like a throat clear: localized telemetry inconsistencies near target field. Nothing to see here, please carry on. Except the people who stare at these words for a living know that's exactly the sentence you write when you need to acknowledge a bruise without explaining the fight. The flow between agencies slowed as if moving through syrup. Weekly coordination notes arrived late and thinner, and when they did, they favoured process over plot. Outside that circle, amateurs and university groups kept publishing their jagged charts and provisional fits, as they always do. Messy, open, and brave. Their curves showed the same drumbeat under different skies, their threads filled with arguments and humility and the odd crackpot theory that everyone politely ignored. In the absence of official oxygen, 1,000 small fires kept themselves alive. People working the midnight shift began to joke that the lack of noise was its own kind of noise. It wasn't a conspiracy board with red string and bad lighting. It was the kind of humour you use when you feel the rails under. You flex slightly and you remind yourself that trains still run on flexing rails every day. Softly, the debate moved from what are we seeing to what is the right way to say what we think we're seeing. Everyone knew the trap. Speak too soon and you break something that can't be repaired later. Credibility, trust, patience. Speak too late and you break something else. Curiosity, honesty, nerve. A small group gathered in a glass room with coffee that tasted like worry and drafted paragraphs that tried to split that difference. They carried a problem bigger than physics. The public wants the truth quickly, and science prefers the truth slowly. Somewhere between those tempos, the data pipeline narrowed to a thread. Further analysis underway. Calibration review in progress. Those phrases did their job, but they also did something unintentional. They turned attention not just to the sky, but to the locked door. Then the door cracked again, just enough to make the room collectively lean. A cropped telemetry plot, anonymous and low resolution, showed a temperature plateau that didn't stroll the way an ice and dust body strolls. The line rose, steadied, fell, like a controlled exhale. If you were looking for drama, you'd miss it. If you were looking for control, you couldn't. The friction wasn't just about whether to release a graph, it was about what happens the moment a graph suggests design without proving it. The instant the word designed gets written down, everything that follows is no longer just science. It becomes policy. Space doesn't care about our categories, but people do. and the people on the hook for the next sentence know exactly how fast an innocent plot can become a headline that changes careers. So they watched the clock slip toward the blind weeks and chose the safest verb in the language: wait. Waiting would be easier if the object weren't so maddeningly composed. The rhythm stayed true, the plume stayed aimed, the orbit stayed neat. The silence did not calm anyone, it amplified the sound that was already there. In the end, the blackout told a story it was trying not to tell. When the numbers get more disruptive, the pipes carrying them get narrower. Maybe for caution, maybe for control, maybe, as always, for both. And while the files trickled, the heat spoke in a voice that was almost polite. 3i Atlas didn't run hot the way a bonfire runs hot, with tongues and waves. It ran hot the way a well-tuned oven runs hot, uniform, steady, stubborn against disturbance. The expectation had been simple. The day side should sizzle, the night side should cool, and the border should writhe as sunlight and shadow took turns. Instead, sensors reading across bands found a smooth field that hovered in a narrow band, as if a single thermostat were wired to 1,000 small hands smoothing the lumps. It is hard to overstate how weird that feels to people who know how space cooks things. Raw sunlight is not gentle. It blasts, then slacks, and everything it touches responds with jerks and delays. But when the sun brightened for a brief stretch, nearby surfaces, rock, metal, even Mercury's baked ground, showed the bump as if nodding to a louder voice. 3i Atlas did something that makes engineers stop chewing mid-bite. It bled heat faster instead of taking more in. The curve flattened when it should have climbed. That's not inertia, that's instruction. Once you see instruction, you start looking for the rest of the control loop. People who build machines that hold a set point in a noisy world use simple tricks. Measure, compare, adjust, repeat. The signs were everywhere once the teams looked with that eye. A soft ultraviolet flicker before each bright phase, like a system priming itself. A narrow window where the temperature sat as if it had been told to sit. A quick, clean drop back to baseline, as if a shutter had closed and the reaction had been denied its favourite food. The magnetometer teams, who usually get thankless slices of attention, became suddenly popular. Their traces sketched a hollow around the object that wasn't just absence, it was structure. Field lines thinned and then swelled in time with the flare cadence, like a bubble breathing. If you've ever watched a Faraday cage shrug off a spark, you know the look of a space that refuses to let stray charge in. This bubble wasn't just denial, though. It seemed to open and close on a schedule. Absorb, hold, release. The room began to murmur words like coupling and conversion, and then, wary of overstepping, wrapped them in qualifiers. There was a neat, almost domestic metaphor that kept returning. Imagine a home with radiant heat and a smart thermostat. When the temperature dips, the system sips energy from the line and keeps the interior even. When the afternoon sun punches through the windows, the system doesn't wait for a sweat. It cuts the feed before the house climbs. The thermal maps around 3i Atlas read like that, except the house was a hurtling mountain. The line was the sun's electromagnetic hum, and the thermostat appeared to be tied to a plume that exhausted metal breath on cue. The surprise within the surprise was how gentle the heat cycles were. A strong heater slams. This didn't. Every pulse looked like a steady pour, 4 counts to fill, 4 to hold, 4 to empty, layered on top of the metronome that had baffled everyone since the first day. Under that rhythm, a secondary beat whispered through the data, a slower swell that didn't line up with any obvious geometry. It was as if a deeper tank inside the system were filling and draining in a longer tide, 4 small beats to 1 large one. Someone scribbled "batteries" on a pad, then crossed it out, not because the idea was silly, but because the word felt too human for what the plots were saying. In parallel, the skin of the object behaved like something you usually only see in factories. As the flares peaked, reflectivity dipped a hair, enough to suggest the outer layer had softened or reordered. Moments later, it brightened back, as if the surface had been relieved of stress and set again. Annealing is a word metals people use for this kind of ritual. Heat to relax, cool to strengthen. You could imagine 3-Eye Atlas humming through thousands of such micro-rituals, smoothing its own flaws, resisting the urge to crack under a star's fist. Skeptics kept doing the job you want skeptics to do. Could a thick, highly conductive shell simply smear the heat around until our instruments mistook uniformity for control? The math pushed back. To flatten a field this well with conduction alone, you'd need material and thickness that would make the object heavier than it moves. Could radioactive decay inside the core be making a space heater that swamps the solar hum? The signs that usually accompany that kind of internal burn, telltale photons, a certain flavour to the spectrum, refused to show themselves. That left something more interesting and less comfortable. Energy arriving from the environment, being harvested in a way that isn't mysterious in principle, even our kitchens know how to do it, and then spent on a schedule. You don't need fancy jargon to understand it if you've held an induction cooktop under a pot. The field hums, the metal accepts, heat appears where nothing seemed to push. Now move the image from a kitchen to a moving cavity in the solar wind, and the pot becomes 3-Eye Atlas, its surface a labyrinth of paths for currents that never have to touch wires to do work. None of this required a proclamation about intelligence. It required only what the curves already describe: measure and respond. The elegance was in the sense that the pieces all helped the others. The bubbles smoothed the incoming storm. The thermal regulation kept the surface from tearing itself apart. The anneal-like cycles mended what remained. The plume dumped what the system didn't want to keep, and, in doing so, gently leaned on the path the way a hand can lean on a pen to steady a line. The most telling test arrived as a gift from the sun. For a brief window, the star flexed a little harder. The instruments around the inner system all nodded. 3-Eye Atlas nodded too, but not the way everything else did. Its heat curve didn't step up. It flattened further, like a singer dropping volume to keep the mix even when the band gets loud. People stared at that line longer than the simple numbers justify, because in that tiny refusal to be pushed you can read a philosophy. The object does not let the star decide its temperature. It listens, and then it chooses. There were quiet debates about the word metabolism. Some hated it, some couldn't let it go, none of them meant biology. They meant a rhythm built for survival, an intake that is not gluttony, an exhaust that is not waste. A loop that doesn't chase drama, only stability. You don't need a mind to run such a loop, you need a design that can take a beating and shrug, then take another and shrug again. If the shrug also inches you forward along a chosen path, then you get something that looks suspiciously like purpose. The strangest comfort of all was how small the numbers were. Nothing in the thermal story bragged. The set point wasn't outrageously high for the whole system, it was simply too even for the surface. The adjustments weren't wild, they were timely. The bubble wasn't a fortress, it was a veil that opened and closed. For the people who have spent their lives trying to imagine how a thing might live inside a star's temper without being torn apart, this humility was an answer they had not known they were hoping for. Not a miracle, just a craft. Heat kept where heat should be kept, and let out where letting out prevents a break. By the time the last clear plots trickled in before the world's instruments had to squint through solar glare, the shape of the story had stopped changing every night. The blank spaces on public pages remained blank. The hallway conversations grew slower, as if everyone wanted to store the feeling of the graphs before the long wait. On a whiteboard, someone drew a loop and didn't label it. Intake, conversion, exhaust. On another board, someone wrote 3 words and underlined them until the marker squeaked. Regulate, resist, persist. When you strip away the jargon, the cautious memos, the missing frames, and the nervous laughter, what remains is simply this. 3-Eye Atlas behaves like a system that refuses to be a victim of its environment. It turns a storm into a hum it can use. It turns a hum into heat it can manage. It turns managed heat into breath that pushes where it wants to go. And when the sun tries to write its story for it, the object edits. That is the heat's testimony. That is what made the silence around the data so loud. The sound was there before anyone dared to call it a sound. A thin, stubborn line threading the noise, rising and falling with the regularity of someone tapping a finger on the table just out of sight. Analysts didn't go hunting for mystique. They went hunting for causes. Solar magnetic waves are messy by nature, broad, wandering, full of hiccups. This line wasn't. It perched near a narrow frequency, then followed 3-eye atlas like a shadow that refuses to be shaken, brightening at the exact moments the object's flares came alive. When they overlaid the two, the timing didn't sit on top of each other like stacked paper. It sat apart by a fixed delay. A beat late, always the same beat late. You could measure the space between the sun's flicker and the object's reply like you measure the space between lightning and thunder. That small delay changed the tone in the room. A resonance can happen by accident. A response implies a listener. No one wrote that sentence in a report, but the graphs wrote it for them. Every time the sun's background note slid a hair, 3-eye atlas slid after it. Not guessing ahead, not lagging behind, just keeping the same respectful distance, as if a receiver had turned a dial until the static smoothed out. On one day the line sat lower. On the next, it climbed a notch, and each time the object paused as if to listen, then retuned and continued. Engineers have a phrase for this kind of poise: lock. Not grip, not brute force, but the kind of hold a musician has on a pitch. The kind that doesn't tire even when the room gets loud. More curious than the line itself was what bloomed around it. At the edges of that narrow band, harmonics appeared like careful echoes, exact multiples stacked like rungs. Nature loves overtones, but not this tidy. In labs, you see that pattern when a signal has been deliberately shaped to carry structure. Data riding on a carrier, not a scream riding on a storm. The teams were careful with their words. They said words like organised and shaped and left words like message in the drawer. Still, the shape kept repeating and the drawer grew hard to keep closed. The plasma noticed. Around the frequency where the lock lived, the wind itself started to ripple in a way that looked less like weather and more like a lane being swept through a crowd. Density dipped and recovered in a slim corridor that linked the sun's surface to the object's position. If you want a picture, don't think of a rope. Think of a bright thread in a sheet, drawn taut, vibrating in time to a note that both ends can feel. Some people began to call it a bridge. Others, allergic to romance, called it ducting. Either way, it looked like energy preferred that path once it formed, returning to it like water returns to a carved channel after rain. The checklist grew longer. Could the line be an artifact of the probe's clock? A glitch in the way downlinked data are packed and unpacked? Teams swapped clocks in the math, decimated and oversampled the streams, shredded the signals and rebuilt them with different filters. The line survived every indignity. Then they asked a question that felt like betrayal to their own instruments. Could the sun be throwing its own voice, making two probes think they were hearing the same thing from two places? That accusation died quickly when an observatory far from the space probe saw the same choreography in a polarization twitch just before each flare, a tiny roll in the axis of light, followed by the brightening, followed by the tidy chemical exhale. 3 senses, 1 beat. You wouldn't notice the power growing unless you lived with the numbers day after day. The line was never loud. It didn't need to be. It grew steadier. The fuzz at its edges thinned, as if the player had found the sweet spot on a dial and stopped fidgeting. The harmonics climbed a step and then held, like a chord that had finished tuning and settled into itself. If you were looking for drama, you were in the wrong story. This was the quiet of a system that had stopped searching and started using what it had found. And here was the strangest part. As the lock matured, 3-eye atlas seemed to lean even more into its other habits, as if the parts of its life were sharing a metronome. The pre-flash and the ultraviolet kept its place in the count. The nickel breath kept cresting on cue. The plume's aim kept circling back to the same point on the sun, even as the geometry changed. Instead of adding confusion, the new order deepened the old order. That's not how accidents behave. Accidents pile on each other and tangle. This untangled. Late one evening, an engineer dragged a finger across a wide plot and said softly, "It's a follow-along." She meant the simple trick that keeps so many things steady in a noisy world. A sensor reading the state of the room. A controller making small moves to erase small errors, over and over until the error can't grow. You see it in thermostats, in noise-cancelling headphones, in autopilots, seeing it in the breath and light and magnetism around a mountain of metal in the inner system took the air out of the room for a moment. Not because the trick is hard, because it is so recognisable. The insistence that this didn't require personhood became a mantra, and a healthy one. A rock can echo, a shape can sing and pushed. But whatever 3i Atlas was doing in the frequency where the sun hums loudest, it wasn't just being rung like a bell. It was keeping time with the bell. How far you carry that thought is up to philosophy, not plots. The plots were content to say what they could. The sun pulsed, the object answered, and the space between the two behaved as if it had been made to carry the conversation. Dash! The first radar echo came back too clean, and the operator didn't believe it. He ran the sweep again. Same answer. A reflection that behaved like it had struck something both conductive and smooth. Not mirror smooth. Space is unkind to perfection. But smooth enough that the returning signal didn't scatter into the messy soup that rough rock prefers. Smooth enough that the polarization didn't flip and splay the way it does when the surface is all facets and pits. The ratio that tells you how much the echo's hand is twisted when it comes back stayed near the line that usually belongs to polished things. People use careful words, specular components, low depolarization, but the plain language translation sat on everyone's tongue, metal that acts like it knows it's metal. Then the timing quirks appeared in the echo, tiny microsecond shifts that rose and fell in step with the flare cadence. This wasn't noise. Noise doesn't keep appointments. When the object breathed brighter, the echo arrived a whisper earlier, as if the skin under the beam had changed and shortened the path or tightened its response. When the object dimmed, the echo lagged back into its quieter place. Those were not the kinds of numbers you build monuments to, but they were the kind of numbers that make you stop trusting your first, lazier stories. On a different night, under a different sky, a small slice of a silhouette sketched itself out from scattered data, just enough to be dangerous to the imagination. The edges weren't jagged in the way landscape is jagged, they were stepped. You could trace ridges fanning from the centre like the ribs of a wheel. Not everywhere, not perfectly, but repeating enough to suggest a plan. 12 is a sticky number when you're thinking about circles. You can't help but measure the angles, can't help but notice how a full turn divides into neat pieces. The teams refused to make a religion out of a grainy outline, but many of them privately wrote the same phrase in their notebooks, repeating geometry. Meanwhile, the thermal story refused to get messy. Every flare was a small ritual. Warm, hold, cool, reset. And the surface seemed to soften and set with each ritual the way a craftsman's metal does when it's taken through an annual cycle. The reflectivity dipped a hair at the peak, then returned, suggesting a thin layer that did not crack under insult but flowed and then fixed. That is not a comet's skin. That is not slag. That is technique. A materials group brought in because the language of fields and heat needed other voices suggested a framework that made some heads nod and others shake. Don't think of the body being held together by bolts and rocks, they were said. Think of it being held together by rules. A lattice that isn't just atoms touching atoms, but magnetic domains obeying a pattern, tightening under a stronger external field and loosening when the anger outside eases. In that picture, the sun is not an enemy. The sun is the clamp. The closer 3i Atlas approaches, the more the clamp squeezes, the more rigid the frame becomes. That flip, danger as reinforcement, would explain why the object grew calmer under stress that unthreads lesser things. Engineers are allergic to adjectives like self-healing, so they didn't use them. They used verbs. They watched the skin change in ways that erased the marks you expected to linger. They watched the radar echo smooth itself back to its tidier timing after each flare. They watched the narrow plume remain narrow, as if a nozzle had shrugged off another hour of punishment and asked for the next. If you have ever seen a pipeline cutaway where residue plates out exactly where the designer wants it to, you know the feeling these graphs gave. Somebody is managing the surfaces. What rattled even the skeptics wasn't the existence of strength, it was the cadence of maintenance. Space destroys on its own timetable. Repair, if it happens at all, is slow and forgiving. The story here was quick and unforgiving. Each pulse left the skin a little different, and then returned it to the same target state, as if a definition of ready had been written into the material, and the material knew how to find it again. You could call that memory. You could call it compliance. You could, if you were feeling poetic in a place that penalizes poetry, call it a body that refuses to keep scars. The combination of smooth echo, measured ribs, obedient heat, and a plume that holds a line left the committees with two honest sentences to choose from, and they eventually chose both. The first, a natural structure, could, in principle, land on this behaviour if the ingredients and the history and the luck were just so. The second, it would be less work to believe you're looking at a framework built to do exactly this. One sentence is an assignment to study, the other is an assignment to prepare. In the lab corners and back channels, some of the best ideas stayed shy. People sketched layered skins where thin, conductive films relayed themselves under current. They sketched ribbed understructures that could flex and lock like the iris of a lens. They sketched chambers that filled and emptied in the same beat as the thermal curve, not pumping blood but pumping charge, rebalancing stresses before cracks could start. All of it was speculation, and everyone treated it as such. But speculation grew disciplined here because the data kept swatting away lazy guesses. If you offered the object an easy failure mode, it declined. Days that should have been the worst for materials were the days that made 3i Atlas look most composed. As the light sharpened and the field outside grew louder, its skin calmed. The radar stopped twitching and held. The ribs, if ribs they were, stood where they had stood before. People used quiet words like robust and resilient, then wrote stronger ones in their own heads. When you see something meet an environment designed to erase patterns, and it answers by becoming more patterned, you remember it. Dash. The calendar became the antagonist. Lines were drawn around dates the way you circle a storm on a chart. Not because you can change the weather, but because there's dignity in knowing when it will arrive. Superior conjunction sounds clinical until you realise it simply means the star will step between you and the thing you can't stop watching, and for a long, bright month your best instruments will be staring straight into an argument they cannot win. The word inside the teams was softer and crueler: the blind window. There's an art to preparing for not seeing. It looks like superstition from the outside, tuning radios to frequencies where you don't expect to hear much, pointing dishes near but not at the glare, asking dusty sensors to stand in for cameras. But it's really a refusal to let the clock make you passive. Arrays in deserts and on islands set their watches to the object's old heartbeat, ready to listen for whispers that might leak through the sun's thunder. If the lock that had tied 3i Atlas to the star's hum kept going unseen, little scallops of pattern could ride the background and reach us in hints. People started calling those hints the whisper, a nickname, nothing more, a promise to their own patience. Practical plans multiplied. The deep space antennas wrote new scripts for the hour the object should return to a tolerable angle. Bounced, listen, bounce again, triangulate, don't trust the first answer. Teams practiced the dance of where is it now with dummy targets, building muscle memory for a morning when the numbers would carry too much weight for the fingers to shake. Somewhere in a folder, drafts of 3 press statements lived side by side like siblings who had not yet learned how different their lives would be. One explained fragments and relief. One explained endurance and awe. One explained deviation and history. Privately, a 4th draft existed in a handful of minds. It had no good title. It explained how to say we can't find it without breaking the voice that would have to keep speaking for months. No one wanted to write that one. A few wrote it anyway, because contingencies you're ashamed to plan for have a way of arriving uninvited. Inside the agencies, the policy rails hummed. If the coordinates after the blind window matched the book could keep being a science book. If they didn't, the book would be moved to a different shelf, labelled with words that change who gets to hold it. The people closest to the data disliked that conversation, not because they were naive, but because they knew what secrecy does to careful thinking. Still, they laid the rails, because rails laid ahead of time keep trains from taking bad curves. Out in the open, the amateurs and the small labs refused to adopt the hush. They traded predictions and tricks, wrote code that would ping a dozen data sources the moment the sun let the sky be sky again, and agreed to call each other in the middle of the night if one of them saw so much as a smear where a point should be. Their feed sounded like a vigil, which is what it was, a distributed promise to keep watch over a place you can't see and to tell the truth about what returns. The days just before the blackout were the strangest of all. 3i Atlas did not hurry, it did not grow erratic, it did not make a grand gesture for our sake. It kept its beat. The plume held its aim, the skin did its small, flawless rituals. If you have ever watched a performer leave a stage with the same poise they had when they entered, you know the feeling those plots gave. No bow, no flourish, only the quiet message that what matters will continue whether anyone sees it or not. In the control rooms, people began to move differently. They put away drama, they tidied code, they backed up what didn't need backing up, then backed it up again. They wrote checklists that others could follow in their sleep. They taped the simplest possible summaries above screens that would soon be filled with more numbers than a tired brain can hold. Don't chase ghosts. Confirm twice. Record everything. Breathe. And underneath the professionalism sat 3 outcomes that everyone could recite in a sentence without looking at notes. Break apart and the story becomes a lesson in how far a stubborn object can get before the star claims its due. Hold steady, and the story becomes one of nature's underestimated grace, a material and a method we did not know the cosmos could teach. Change course, even a little, and the story stops belonging only to science and starts belonging to history. In the last clean data, a few extra curiosities made their appearances like friends at the door before a long trip. Small modulations hidden under the main lock. A soft rise in the saturated heat that felt less like strain than like a system firming up. A final tight stack of harmonics like the lines on a face that has decided what expression it will wear for the next hour. Each was a temptation to overinterpret. Each was also a reminder of the one humble truth the plots have enforced from the first day. 3i Atlas is not asking to be believed in any particular way. It is asking to be measured, then measured again. It will do what it does in the dark. We will learn what that was when the light returns. So the schedules flip to the weeks of waiting. The listeners tune their ears. The watchers put their hands in their pockets. The planners stationed their words within reach. Somewhere behind the glare, the object kept breathing, counting, smoothing, holding. The rest of us did the only thing left that matched its discipline. We kept time.